Okay, so in our previous video, we understood that there is something that it's called ventilation perfusion ratio, and we understood that this ventilation perfusion ratio is just a small equation, and what this equation could help us with is that it's going to give us a value that could makes us understand a lot of things, okay, and what actually is happening in other situations. Okay, and we'll talk about some examples, but now we haven't yet finished from measuring the two sides of ventilation perfusion ratio. We're done of perfusion. We know that perfusion actually equals 5 liters per minute. And what we want to do right now is try to measure ventilation. And actually, ventilation stands for the amount of fresh air that enters your lung. Okay, this is ventilation. And what I want you to understand is that the amount of fresh air that enters your lung, this sentence is a little bit tricky, and you may see that there's nothing tricky about it, but let me just highlight a word. The word is amount. The word amount, if you think about it, it's a changeable word, so this is why it's tricky. For example, if I have 5 liters and if I have 10 liters, they are both an amount, but they are very different from each other. So what about if I have 5 liters and if I have 100 liters? This is very different, but they are both an amount. And why I'm saying that? I'm saying that because actually lung is a stretchable organ. It's a stretchable container. It's like a balloon. You can fill it up with a small amount of air, but also you can fill it up with larger amounts of air. And the smaller and larger amounts of air, you can actually now experience them, and they are one of them. It's called passive breathing, which is the small amount, which is what we do normally. We breathe unconsciously, rhythmically, without even thinking about taking our breath. And in this passive way, in this passive breathing, we actually get 500 milliliters inside our lungs. But if you wanna expand your lung more and more, then you're going to go through something called active breathing or deep breathing. And you can try it right now. Try to take a very, very deep breath. And when you take a very deep breath, you can feel your chest cavity expanding. So you're actually getting more air. So this is why an amount is tricky, because if I want to put V in my equation, am I going to put 500 ml, or am I going to put a bigger number instead of V? Well, actually, we are going to just try to not think about this, because this is actually it's not the normal way that we breathe in. Passively, we breathe passively normally. So this is our volume. But another thing that I want you, and actually this thing, which is the amount of fresh air that enters your respiratory system, not your lungs, not only your lungs, but also your respiratory system, it's called tidal volume. And it's easier even for me to say tidal volume instead of saying the amount of fresh air that enters your respiratory system passively. Okay, so tidal volume just equals 500 mLs. Okay, and now we have the basis of trying to measuring V, but there are some other things. What I want you to see is that I want you to see this picture. This picture shows your respiratory system, and if you saw the definition says that V is the amount of air in your lungs. So imagine with me that you're taking your breath, and air is entering here through your nasal cavity and through your pharynx, and then larynx, and then your tracheas, and it's taking all this long way until finally it reaches your lungs. So in one breath, you're actually having two compartments. You have a compartment that it is able to take that fresh air and make use of it. It's able to take that air and give it to the body, because actually there's alveoli here. And you have this area that actually just conduct the air to the lungs. It's not able to take up oxygen and give it to the body. And this area, they call it anatomical dead space, and it is a dead space. And so what we actually want to measure this area right here. So we want to subtract this area from the whole tidal volume, which is 500 ml. So what we're gonna do, the scientists measured this area, this yellow area, and they said that it's about 150 mLs. So what we're gonna do is we're gonna subtract 500 from 150 ml, and then we're gonna get 350 ml, okay? So this is the first thing in measuring V. But there's one thing that you need to watch out for, and it's the last tricky thing about measuring ventilation perfusion ratio. If you saw the equation says V over P, and actually in some textbooks, or in all the textbooks, it's written V over Q, but actually I just wrote it P for the sake of simplicity. Anyways, V over P equals, we know that P is 5 liters per minute, and we need that the both units up and down, we need them to be equal. So now we have 350 milliliters. So what we are going to do is that we're gonna see every time that this person takes his breath and gets it out, how many times he takes his breath in 1 minute. So we can measure the two values, and we can do that by what? By multiplying. So let me write the basic equation for V. V equals the tidal volume minus the anatomical dead space, and we're going to multiply it by something called RR, or it's the respiratory rate, which how many times you take your breath in 1 minute. And this is going to enable us to make the two units equal, okay? So what we are going to do, we're going to take 350 and we're going to multiply it by an average of breath, how many times an adult person takes his breath. So, and actually the number is 12. So we're going to multiply 350 by 12, and it's going to give us 4,200, okay? So you have 4,200 milliliters per minute. And you can say, if you divide this over 1,000, so it's going to be 4.2 liters. And now let us measure this thing and know what X actually stands for. Okay, so 4.2 divided by 5 equals 8. Okay, so 0.8, sorry, so 0.8. And this is the average, the normal value of ventilation perfusion ratio.